Now that you know how to multiply polynomials, we are going to look at two special kinds of products. The first one is called the difference of squares. Notice that both of the binomials are exactly the same except one is plus and one is minus. So if we are doing the FOIL method, the first terms are x and x. So I have x times x, which gives me x squared. The outside terms are x and negative 3. Negative 3 times x is negative 3x. The inside terms are 3 and x, which would give me 3x. And the last terms are 3 and negative 3, which would give me negative 9. I can then combine any like terms and then write my answer in standard form. These two terms are like terms, so I have x squared. And then notice with the like terms, negative 3x and 3x, those are opposites of each other, so those technically would cancel each other out. And then I'm left with minus 9. So looking at what happened here. What happened here was basically the inside and the outside terms canceled each other out because they ended up being opposites. With this being a difference of squares, you will have that happen every single time. So the quick way of doing a difference of squares is this. It's the product is the first term squared. So I would have taken my first term, which is the x, and squared it, which would have given me this. And then minus, because the signs are different, so it gives you a negative. And then it's the second term squared. So the second term is 3. 3 squared is 9. And it's always going to be minus because one's going to be positive, one's going to be negative, so we'll always make that a negative. So looking at this now, you may be asking yourself, okay, so yeah, it saves like 30 seconds of time, but why is that important? It's important to understand these special products because later on we're going to be doing something called factoring, which is being able to go from the final product back to the two binomials, or in some cases polynomials, that are being multiplied to get it. So it's easier to go backwards when you recognize that x squared minus 9 is a difference of squares. The other type of special product is the square of a binomial. This time, if you're looking at what you have here, you have x plus 2 times x plus 2, or because those both of the binomials are the same, you could write it as x plus 2 squared. So let's take a look at what happens here. The first term in my polynomials, if I was foiling, is x times x, which would give me x squared. The outside terms are x and 2, which gives me 2x. The inside terms are 2 and x, which again gives me 2x, and my last terms are 2 and 2, which gives me 4. So when I combine my like terms this time and put my answer in standard form, I would have x squared, and then let's notice what happens this time. The inside two terms aren't opposites anymore. They are exactly the same. So I have 2x and 2x. I have two of them, so that technically gives me 4x. And then there's nothing to combine with the 4, the constant term, so I have 4. So my final product is x squared plus 4x plus 4. When you have a square of a binomial, that middle term is always going to be identically the same. So to take a look, shortcut of this would be the first product, or the first term in the product is the first term squared. So the first term is x, the first term squared is x squared. Then it's either going to be plus or minus, depending on what is inside the parentheses. So in mine, I have plus, so that's why this is a plus, because it's a plus here. If it was a minus there, it would be a minus. And then it would be, it says twice the product of the two terms. So if I take my two terms, x and 2, and multiply them together, I get 2x. Twice that gives me 4x, right? Because 2 times x is 2x. And then 2x, if I have twice it, means multiplied by 2, which gives me 4x. And then my last term is still 2. So my last term squared is 4. That's where that comes from.